Good morning from Redmond, everyone. My name is Daniel Jacobson, and I'm a program manager on the Visual Studio team. Most of my job is working with tools for Universal Windows Platform developers. Today, I want to talk to you about .NET in Universal Windows Platform development. I want to tell you how the skills you learn are really powerful and how you can build an end-to-end solution just using the same set of .NET technologies, whether it's server, client, or even IoT device. Before we get started, though, I kind of want to give a little bit of historical context. So as I'm sure many of you are all aware, that the real power of Windows 10 and the Universal Windows Platform is being able to target so many different device families. However, a lot of demos still just utilize a simple UI adapted across multiple devices. For this demonstration, I wanted to show two separate applications, one that's tailored specifically for the IoT device, and then another that's tailored for desktop and mobile. In addition, I want to take advantage of lots of different services that Microsoft has to offer that can really kind of power your Universal Windows Platform toolkit. But before we get into the actual application itself, I want to talk about .NET and the Universal Windows Platform and why it's really important to you. So if you recall, the .NET has kind of an interesting history. There was a set of platforms that all ran on a separate app model, a different framework, and a different runtime. While all of these platforms had many similarities, they were still not quite the same. This made code reuse more difficult than it needed to be, and the skills you learned for one platform did not necessarily translate one-to-one to the next platform. So if you are an excellent WPF developer, for example, that may not mean you're the best Windows 8.1 developer. However, in 2015, we announced .NET Core, and .NET Today is kind of evolving extremely rapidly. So you continue to have your traditional desktop .NET framework that powers Win32 applications such as WPF and WinForms. In addition, you have .NET Core, which is our more modular, cross-platform, open-source framework that powers modern application needs, such as the Universal Windows Platform, or ASP.NET Core. Finally, you also have the mono-based runtime for Xamarin, which you just saw, that can power iOS, OS X, and Android device applications. So .NET is really becoming more and more powerful. Each of these frameworks, again, is a little bit different. The traditional .NET framework shipped within the operating system. That meant if you wanted to ship an application that took advantage of the latest full .NET framework on the desktop, you needed to make sure that your customers had that version of the .NET framework already installed. With .NET Core and Xamarin, though, the version of the .NET framework is actually shipped app locally. It is shipped within your application. This allows you to innovate much faster. As soon as a new version of the .NET framework or the .NET Core framework is released, you can go ahead and take advantage of that in your application. That's really powerful. Finally, as you can see here, each of the different modern frameworks, again, has a slightly different app model and different base libraries, which made code reuse a little bit more difficult. But we tried to tackle that problem with the concept of portable class libraries. And what that means is that there was reference implementations for each of the kind of .NET base class libraries, and you could write your code on top of those reference implementations and then share them across these different frameworks. Well, that's the world today, and it's pretty awesome. But it's only going to get better tomorrow. Soon, the .NET Standard library will kind of be the shared code standard going forward. Each platform can it can declare that it supports a version of the .NET Standard library, and then any platform that supports that version or above can share the exact same base class library surface area across each of the platforms. This allows innovation to occur at a much faster pace. I know many other talks have already talked about this, but what this really means to you as a Universal Windows Platform developer is that as you hone your .NET skills with Universal Windows Platform development, those same set of skills will transfer across any of the .NET Standard platforms. So no longer are you just mastering your skills for a platform, you're mastering your skills for an entire technology, and that is the .NET Standard. Reusing skill with the .NET Standard is going to be much better. You'll be able to master a single library, and as long as the platforms you're targeting implement those versions or that version of the .NET Standard, that code will reuse one-to-one. It's awesome. In addition, you'll have a big surface area to utilize for your .NET code. There will no longer be a small common denominator as it exists with portable class libraries. With portable class libraries, you can only reference the APIs that are available in each of the platforms that you set your portable class library to target. With .NET Standard, that is no longer the case. And finally, .NET Standard can grow without updating platforms. I mean, you can iterate on the .NET standard and change the version number, and existing platforms just don't have to update that they support that version until they're ready. So you can still share your code for those platforms, but you can continue to innovate faster. So finally, I want to actually get into .NET very specific features for Universal Windows Platform. The first one is, how is the .NET Core actually delivered with the Universal Windows Platform? I mentioned that .NET Core is a framework that is delivered as a part of your application itself. So with Universal Windows Platform, the .NET Core framework is delivered as a set of NuGet packages packaged within your application. What that means for you is if a new version of the .NET Core meta package is released, or even a pre-release version of a .NET Core library is released that maybe fixes a bug that you have or improves performance significantly, you can go ahead and actually manage your NuGet packages and reference those libraries directly. No longer do you need to wait for a full framework to be released and then all of your customers to install that full framework just to take advantage of the latest and greatest .NET technology. It's pretty awesome. The other technology that's really important with the Universal Windows Platform is .NET Native. .NET Native takes your MSIL binaries that are output from the C# compilation and compiles those further to native binaries. And what that means is you no longer have any just-in-time compilation at runtime. Everything is pre-compiled into your package. That means there's a much leaner runtime and startup is lightning fast. We've seen improvements between .NET Native compiled packages and non-.NET Native compiled packages of up to 60% faster startup. One example is that the Xbox dashboard starts up in about 300 milliseconds, and I'm sure many of you have witnessed kind of how big that application is. Finally, we've even heard quotes from customers. One customer said that it saved them 3 months of performance work that they traditionally would have had to do without .NET Native. It's really powerful. In addition to the lightning fast startup, these typically have a lower memory footprint too. On average, we see about 40% lower memory consumption from an application that is compiled with .NET Native compared to an MSIL application. One thing that's kind of unique about .NET Native is with the Universal Windows Platform, the store does the .NET Native compilation on your package. And the reason the store does this is just in case there were ever any security issues identified with the .NET Native compiler, we have a history of your package, MSIL binaries, that we can recompile and send an update to your customers to fix that without you having to resubmit your package. Now this hasn't happened yet and we don't expect it to, but we do have that freedom just in case. And as I mentioned, you have applocal.net, so you can really tailor your targets as you need to. Finally, with .NET Native, your workflow needs to adjust slightly from what you're traditionally used to. So when you build a debug package in Visual Studio, by default, you're building the MSIL binaries that are running against the core CLR. However, when you switch to a release build, you're actually compiling your application with .NET Native. What this means is you should test more regularly with release mode. It should no longer just be your go-to when you're ready to publish. And the reason this is important is .NET Native is still a new technology, and it's evolving very rapidly. It's already significantly better than it was when it was released not too long ago. But that doesn't mean you shouldn't continue to test .NET Native on a regular basis. I recommend about every 4 hours of development or so. The last thing you want to do is 3 months of development work and you're ready to publish, and then you test release mode, and all of a sudden it doesn't work, and you have 3 months of code to dig through to figure out what broke it. In addition, with the Universal Windows Platform, you could be targeting many different devices and many different device families. Before you ship any application, you should always ensure that you've tested your app on the devices that you expect your application to run on. So if you're shipping on an IoT, you should test your application on different IoT devices that you may expect your application to run on. Finally, when you're ready to submit the application into the store, you need to make sure that you upload the right package. Visual Studio tries to guide you to success. When you right-click on the project, go to Store, and create app packages, you will generate the AppX upload if you say that you want to upload to the store. This is the only package that should ever be uploaded to the store, and this is the package that contains the MSIL binaries needed for the store to compile to .NET Native, as well as the store metadata needed for any sort of associating with your store information. So make sure you always upload the AppX upload. So that's the quick history of .NET and Universal Windows Platform development. A lot of that may have been review, but now I want to get into actually building an application. And not just a single application, but multiple applications. One for the desktop and mobile, one for the IoT device, an ASP.NET REST endpoint, as well as shared code across all of them. And the application idea kind of came to me when a friend approached me saying that they wanted to open up a small business, a small store. And they said, I really want this to be successful, so I want to go into this with the mind that I'm going to optimize on everything. And I want to be as efficient and as cheap as possible so that I don't go in the red very early on. So what they had in mind was they wanted to figure out how many people should be staffed at their store, in this case it's a coffee shop, at different times of the day and different days in the week. In addition, they wanted further information just for their own use about how successful their promotions are, etc. So some of the questions we came up with that we wanted to be answered with technology is, how many people are currently in my store? I want to know, all right, it's 2 p.m. on a Saturday. It should be busy right now, but there's only 4 people here. How can I get more people in? How can I tell when someone enters my store and I'm not around? Since it is going to be a small location, what if I'm in the back doing inventory and someone enters my store and I'm not there to greet them? Well, I want to be able to get a notification that someone has entered my store. Finally, I want to know how many people enter throughout the day and at different times throughout the day. I want to know, is 8 p.m. the busiest time of the day during the week, or is it sometime earlier? Finally, I want to know what are the busiest days of the week and how successful are the promotions that I run. So is it the weekends are the busiest? Do people just have more free time to drink coffee? Or do business people come in the morning to get their cup of joe? And in addition, if I track week over week how many customers are entering my store, I'll be able to determine if a promotion was successful. For example, say I run a 2-week promotion and I notice a huge spike in traffic for those 2 weeks. Well, I may continue a promotion similar to that. So the way we decided we were going to actually build this was using 3 main applications and a suite of Azure services. The first application is an IoT application that actually detects when someone enters or exits the store. In this case, when someone enters or exits, an event is triggered and a post message is sent to an Azure web app that is listening for the response. As soon as the Azure web app gets the post message, it's going to write to a backend database using DocumentDB or DocDB, which again is hosted in Azure. In addition, when the post and when the writing operation to DocDB is complete, it will send a push notification to the data visualization client application, which I will have on my desktop and my phone. Finally, when the data visualization app is launched or the push notification is sent, the data client app will send a GET message to the Azure web app, which will then read from the document database and return a list of all the events that have happened. Then there will be some post-processing on the client to cut down on server costs and updating of the UI so that I can see, okay, this is what it looked like over the past 5 weeks, or this is how many people are in my store. So to get started with this, I just want to go ahead and put this thing together. I think logically, and as we looked at this chart, we determined logically that the first application to build is the Azure web app. Both the IoT device sending the post message and the data visualization client app sending the GET message have a dependency on the Azure web app working properly. In addition, the Azure web app is the only one actually communicating to the database, so we can hook all of that up right away. Now this isn't an ASP.NET talk, so we're going to briefly cover what the Azure web app does, and then we're going to spend most of the time building the IoT application. So let's go ahead and get into Visual Studio. To get started, I already have a solution that is essentially blank with a portable class library. Inside of my portable class library is several object models that I'm going to use for both the IoT application, the ASP.NET application, and my data visualization client. Triggered event is the main object, which is essentially what happens when someone enters my store. Well, it only has 2 real properties: the event type, did someone enter or exit, and at what time did they enter or exit, so event time. These other models are used mostly to display to the UI and do data operations on the client application so that I can visualize them in a meaningful way. So we don't need to spend too much time on those. To get started with my ASP.NET application, I'm going to add a new project, go to ASP.NET Web Application, and call this Event API. I'm going to click OK. Select Web API, and I'm going to choose not to host in the cloud because that will prompt me to create a new app service. I already have an existing app service that I want to publish to. So let me select OK. And as this is creating, let's take a look at my Azure resource group, just to show you all the services we've created. So I've created a Shop Analytics demo Azure resource group that contains all of the services I want to take advantage of, which includes my document database, my service application insights, which we're not going to worry about for this talk, my Azure notification hubs namespace as well as my notification hub, and then the app service itself that's going to host the REST endpoint. If I take a look at the document database, there's actually some powerful tools within the Azure portal itself for me to make sure that everything is working. The way document database works is that you have a document database account that can have multiple databases within it. Each database can then contain collections of documents. So each database can contain multiple collections, and each collection can contain multiple documents. For this example, though, it's a pretty simple data model, so we only have a single document that's going to keep a track of all of the events that have occurred. So I've already gotten the template of this document written up. I gave it an ID so that we can reference it in the code, and I've created an empty list of records, and that's where we're going to be writing to. So I'm going to leave this open for now, and we're going to return to this after we test our ASP.NET application. So in my ASP.NET application, I'm now going to add an existing controller. I'm not going to write the controller here, but I've already previously written it. So let me go to my desktop. Oof. .conf, event API, event controller. So we'll quickly take a look at this controller, and then we'll publish it to our live service and see if we can get it working. So within my event controller, I can see that I have a simple get and post method. Oh, before we get started, though, I forgot I have to add a couple of references. The first one is actually to my portable class library, because I'm going to be using some of the object models defined there. But before I even do that, my portable class library, and this is a limitation of PCL, targets .NET 4.6, not .NET 4.5. So let me change my ASP.NET application target framework to 4.6 and add a reference to my PCL. Now if I return to Event Controller, I can see there's still going to be a couple squigglies. My using statement for Microsoft Azure Documents and Documents Client are missing, and that's the document database NuGet package. In addition, I'm sending a push notification from this controller, so I also need to add the push notification hub's NuGet package. So document DB, let me search browse. Microsoft Azure.documentDB is the NuGet package I need, and this should resolve the reference for the first two. As that's restoring, let's take a look at the code. So the first thing I do is define the metadata about my document that I want to read and write from. That is the main function of my ASP.NET Web API. I want to send an event when an event is triggered, and I want to read from the event when the client application is launched. Now that that's completed, let's finish this with the push notification hub NuGet package. Push notification. If I scroll down just a little bit, Microsoft Azure.notifications hub, I just saw it. Where'd it go? There we go. Perfect. So let's restore that, and everything in my application should now work. Let me save this, close it. Cool. So the metadata for my document includes a primary key that is within Azure, and that is currently stored in a resource file. I don't want to expose that to everyone. In my get method, I can see that I'm actually getting the document contents in read document. So response gets the document object from document DB, and I wrote a method for that. Read document reads the document contents, and then I serialize it into a J or I list of triggered events, and that is ultimately what I return. So when the get method returns, it returns a list of all the triggered events, which is exactly what I want to do. The post method, again, gets the document, reads the document, and then writes to the document by adding a new event. So events is essentially all of the listed events in my document, and then I add a new one, and then I set the property value of records to my new list of events, which includes the newest one that I just added, which is the parameter of the post method. And notice I can actually use my object as the parameter for this post method. I can pass that through from the IoT client. It's really cool. Finally, I will await the response by upserting the document, so I upload the new file, and then I send a push notification to the client so that I can update the UI and see when someone has entered or exited my store. So that's pretty much it. That's the only code I needed to add to create my API from new project. So let's go ahead and publish this now. See if we can actually get it working. So I'm going to select an existing app service. I've got my resource group that we just saw. I'm going to click OK. It's going to load. The next thing I'm going to do is change this to debug so that we can operate debugging on this. And then I'm just going to hit next. I don't need a preview. I'm just going to hit publish. So this is now going to publish this service, or this API, to my live running service. Next, we're going to actually see if it works, and we're going to try to debug it to make sure it works. So one of the great things about working with experimental and new builds of Visual Studio is playing with all the latest technology, but every now and then you snag a bug. And there's one little issue that I'm experiencing with this version of Visual Studio with attaching to my live process, but there is a workaround. So the first thing I want to do is show you how this would normally work. You can navigate to either the server or Cloud Explorer and log in with your Azure account to find the app service running. And here I have my live app service, and I can see that it was just deployed. So here we go. And I would right-click, Attach Debugger. So in this case, the debugger will attach, and it will find the process to attach to, but it's been having issues downloading some of the symbols if I do it this way. So what I'll have to do is actually use debug attached to process, and I can navigate to my live service to get the symbols. So just to confirm that that's happening, let me first set a breakpoint on the post method. So as you can see, post method, no symbols have been loaded for this document. That's all right. I'm going to go to debug attached to process and try it this way. So let me navigate to my shop analytics service. Uh-oh. That happens every once in a while too. But that's all right. We'll just try this one more time, and then this should handle the credentials. So let's go debug attached to process again. There we go. So now I can attach and see all the processes running on my live service. And the one I want to attach to is w3wp.exe. And that's essentially what right-clicking in the server or Cloud Explorer does. So now I'm loading my symbols. Great. The next thing I'm going to use is a web debugging tool to actually just send a simple post message to make sure everything is working here as I would expect it to. So here we go. Symbols are loaded. I can use Postman to post to this actual live running service. And what I'm going to do is just post a message from today. So it is currently June 8th, and I'll just pick some random time, and I'll click send. So here we go. Visual Studio is loading, and it's going to hit the breakpoint. And there's a little bit of delay because it is a live web service. Awesome. So the next thing I want to do is actually just await the end of the response. So I'm going to set my next breakpoint before I send a push notification. And then I'm going to watch that property. So response equals await document upserted. So now what I can see is response.resource should contain the content of the document that I just uploaded. Response.resource. So here we go. I can see ID, event stock, records. Now there is a single record, and that is the only record. Whoops. So there's a JSON that should have been uploaded to my document, minus the stuff at the end. That's just the docdb API information. So now what I can actually do is take a look at my document DB document in Azure portal. So let me refresh the document explorer and open up my document, and there you have it. So I can see that my post method is actually working properly. Awesome. So now that the web application is ready to go, I guess I can go ahead and continue execution of this method, and I'll actually leave the debugger attached for now. So as you can see, I get a push notification because this device is already registered. So the next thing I want to do is open up Visual Studio 15 Preview 3. And here we're going to build the IoT application. So I'm going to open up the existing solution on my desktop. And this should only contain my portable class library as well as my ASP.NET application. Perfect. The next step is to add a new Universal Windows Platform project to this solution. So I'm going to start from blank app, and I will call this IoT Client. So as soon as I try to create this new project, I am prompted with a dialog to select my minimum version and my target version. This is something also unique to the Universal Windows Platform in terms of Windows platforms, and such that I can write adaptive code that takes advantage of the latest and greatest APIs within Windows and still runs on lower versions of Windows. And it's really easy to do. But there's tons of demos and documentation about that, so for now we're just going to target 10.586 with a min version of 10.240. This application should work on both. So as soon as I create that. And for those of you who have worked with IoT devices in the past, you'll know a lot of the code is boilerplate code to just initialize the pin board. The first thing I need to do, though, since I'm going to be working with IoT-specific code, is add a couple of references. The first one I'm going to add to the IoT extension SDK, Windows IoT extensions for the Universal Windows platform for my target version. In addition, I'm going to add a reference to my portable class library since I'm going to be reusing some of the object models. And that should be all I need for references. As soon as those references resolve, I don't need app.xaml.cs, but I do want to work within the main page of this application. I'm going to copy and paste some of the boilerplate code you'll find in pretty much any IoT sample, and then we'll add the stuff of interest for our specific application. So let me open up this code. Whoops. Went to the wrong folder. And we'll quickly walk through this. Within the page definition, I'm going to see a whole bunch of stuff, and I'll walk you through it as we go through. So the first thing I'm going to do is define the base URI of my Azure Web Service. This application is going to be sending post messages to that web service, so eventually I will need to create an HTTP client object to send a post message to this live service. In addition, I define all the pins that my hardware is using. So this device has 2 IR beam sensors to track exit and entrance of the store, and also 2 LEDs as status indicators for when one of the IR beam sensors is broken. Finally, I will also declare my pins for those 4 hardware devices, and I'll initialize them when I initialize the board, as you'll see in a moment. The last couple things I have are the HTTP client that I just mentioned I would need to send post messages to my live service, as well as 2 booleans, and this is going to be how we figure out the logic to track entrance and exit. We'll review that in just a moment, though. The other method I have is init gpio, which is just going to initialize the GPIO controller with all of the hardware devices that are connected to it. So as you can see, I'm going to open all of the digital pins for the pins that I've declared for my 4 pieces of hardware. If there is no GPI controller on the device, I will display a message to the UI so that the app doesn't crash, and then I'll just exit this method. Finally, I have 2 types of devices on here. I have output devices and input devices. You can think of the IR beam sensors as just a button with an on and off, and when the beam is trapped, it could be the on state, and when it's off, it could be the off state. So that is an input device, just like a button would be. The LEDs are output devices. I cannot interact with them. All they do is either display light or do not display light. Finally, I set a debounce timeout for my input devices, which will help reduce noise and false triggers. The last thing I have is 2 event handlers for when the value of the entry sensor and the value of the exit sensor has changed. So I'll go ahead and create these methods right now just by using control dot. In addition, gpio status is referring to a text block that I have not yet created. So I'll return to the actual XAML, and I'll just write this in the XAML real fast. Text block, name equals gpio status. And I'll make it so we can actually read it by putting it right in the middle. Vertical alignment equals center. And I'll make it nice and big so we can read it as we run it. Let's return to the business logic. GPIO status is now resolved, and everything should compile. Before I run this, though, I want to do 2 other small things. I want to actually create my HTTP client object in the main page constructor. So let me navigate to the main page constructor. Client equals new HTTP client. And then base address equals new URI, base URI. Oops, base URI. This is my actual string. And that will create my new HTTP client that I can then send a post message to later. In addition, I actually need to initialize the GPIO pin board by executing the method that I copied in here. So now the next thing I want to do is figure out how is this all going to work. So I'm actually just going to run this and make sure all of my devices are working properly and place a breakpoint when the value is changed on either one of these devices. So to deploy this application, I'm going to set it as my startup project. Change it to ARM since I'm running on a Raspberry Pi 2, and then select remote machine. I've already written down the IP address, so hopefully this will work. So the very first time you deploy to a Raspberry Pi 2, It takes a little bit, but that's understandable since you're working with a $30 computer. So as this is sending over the application, let's take a look at what exactly it's going to do. So I've drawn a little map of how this device works. I have two entry sensors, or a single entry sensor and reader, or light and reader, and then a single exit infrared light and sensor. What's going to happen is someone is going to walk through my door and trigger the entry sensor first when they're coming into my store. At that point, I'm going to set the Boolean value for enter to true. Exit will still be false. No event has happened yet because only one of the sensors has been triggered. They haven't fully entered my store yet. As they continue to walk through, they will next trigger the exit sensor, and then I will set my Boolean value for exit to true. Or what I could do instead is trigger the event because I know enter is already true and exit sensor was just triggered. So at that point, I will trigger an event with the parameter saying, this is true, someone just entered my store, they did not exit my store, and then I'll reset the state. So I'll return both Boolean values to false. And this is the simplest way to do it, but what we'll do here is see if this is finished deploying. It's finishing up. Here we go, perfect. And can my minion switch the screen? So behind me, you should see the application running. In just a second. Deploy succeeded, perfect. Can we switch the screen to the IoT device? There we go. All right, so registering the application to run from layout. Should finish in just a second. And this is really the only time it'll take this long. We will give it just a sec. It looks like something may have hung. Let's take a look. Oh, it's still doing something. There we go. So here's my application running. And don't worry, that pain only happens the very first time you F5. You'll see in just a moment as we continue working on this application. The screen should show up, and it should say that my GPIO pin board is initialized correctly. Excellent. Can we switch the screen back? So as I'm debugging this, I'm actually going to trigger these sensors. So the first thing I'm going to do is wave my hand across this. Is the screen switched back to the PC? There we go. So as you can see, the exit sensor value change was triggered, and I can inspect some of the values. So the value of interest and the value of how I'm going to compute these operations is in the arguments. As you can see, edge is falling edge. And what that means is when args.edge is falling edge, that means the beam is broken. When the beam is unbroken, this will change to rising edge. So I can use that information to kind of pivot on whether or not the beam is broken or unbroken. So let's actually stop the continuation of this code and write the necessary code we need to finish. So in exit, actually, let's work with the entry sensor value change one first. The code will be pretty similar. So first thing we want to do is check, is the beam broken or unbroken? So edge dot toString dot equals falling edge. Let me make sure this is right. Yes, I think that's right. That means the beam is broken. Beam is broken. The next thing I want to do is if the entry sensor is triggered and the exit sensor has already been triggered first, that means someone is exiting the store. So let's check if exit is equal to true. If exit is equal to true, I'm going to create new event because that means both of them are now true. Create new event, and I'm going to pass in true. So this method doesn't exist yet, but we'll write it in just a moment. So I'll create it here. In addition, I will reset the state of my device. So I will set exit to false and enter to false. If exit is not true, that means, okay, someone just hit the entry sensor for the first time. So that means I will set enter to true, so that if someone hits the exit sensor next, I will know to create a new event. Next thing we can do is just redo this code for the exit sensor. So let's do the same thing here. Create new event false. Let's change this to if enter is equal to true. Otherwise, we set exit to true. Now, the last thing we want to do for these methods is actually turn the lights on or off so we can visualize that everything is behaving as we would expect it to. So let's change the lights. So if it's equal to falling edge, we want to turn the light on regardless. So what did I call these? I call it entry light and exit light. So in this case, I'm doing exit sensor, so I'll call it exit light dot write gpio pin value dot low. This will turn the light on. Otherwise, I will write the same thing in an else method here, telling it to write high. And I will do the same thing for this method. If the beam is broken, before we even check anything, let's turn the light on. But let's make sure we turn the right light on. Enter light. Oops, entry light, my bad. Now, same thing over here. We need another else statement because the beam is unbroken. Else, entry light, high. Awesome. Now let's see if everything is working as we would expect it to. Make sure that these events are triggered and the lights turn on and off, and then we'll finally write the create new event. So I'll deploy this application again, and I will set a breakpoint at create new event. As you can see, the deploy has started, and it should be significantly faster this time around. Copying files, deploy succeeded. As soon as the debugger kicks in, cool. Let's look at my breakpoint. So this should only be triggered after I trigger both of these sensors. So let's just trigger the first one and make sure we do not hit the breakpoint. And as you can see, the red light turns on. So no breakpoint has been hit, and the red light turns on. Now let's trigger the other sensor and see if the breakpoint gets hit. The yellow light turns on, and my breakpoint is hit. Both of those were triggered. I can actually see if that was an exit or an entry just by inspecting the Boolean value v. So in that case, that was an entrance event. So this is the direction of my doorway going into the store. If they were to come the other way, it should be an exit event. Excellent. So now that we have all of the hardware working the way we would expect it to, and we're creating a new event, we can actually post this new event to the Azure API. So what we're going to do now is actually create an HTTP content to send with our HTTP client. But before we do that, I'm getting ahead of myself. Let's actually create the new event. Triggered event, and this is where I need my PCL, e equals new triggered event. E.event time is going to be right now, because as soon as this event is triggered, that's when we want to record the event happening. And e.event type is going to be set to v, whatever event type it is. The next thing I want to do is create the HTTP content to send to my Azure endpoint. So I'll call this content post because it's the content I'm going to post. And I'll create new string content. First thing I want to do is actually send the content. So string content is going to be the serialization of my application, or of my object, sorry. JSON convert. Let me use dostuff.json.serialize object e. Let me create a new line so you could see. Next thing I need is the encoding, system.text.encoding.utf8. And finally, I need the media type. And in this case, we're sending JSON, so it has to be a JSON message. Application.json. Oops, not .json, /JSON. Finally, let's actually send the content now that we've got the content created. HTTP response message equals await client.post async. Now I need to actually write in the string request URI. So my base URI is simply, if we take a look, shopanalyticsservice.azurewebsites.net. I do not have any of the API information. So if you recall, when we did Postman, I actually have to append API/event to the end of that. So that's what I'm going to do here. API event. And then content post is the content to post. So, whoops, I need to make this an asynchronous method because it's going to asynchronously create a new event. Cool. And that should all work now. Yep. Now let's test it. So let's place a breakpoint at the end of this and make sure that the message we are getting back is the message we would expect to get back. right, my IoT application should be ready to go, loading symbols, perfect. So let's create an entrance event. So if I swing my hand this way, it should create an entrance event. So I see the red light, I see the yellow light, and then it pauses because it's going to hit a breakpoint. So the light's not going to yet turn off because it breaks before the value changes again. All right, so here we go. And let's just hit F11 and inspect what message is, which will take just a second because it is a live service. Whoa. Awesome. So I actually forgot. I left the debugger running on my live app service. So let me put these side by side. I have two instances of Visual Studio. One is debugging the live web service that actually listens for the post message. And the other one is debugging the IoT application that sends the post message. So if I was getting any wonky behavior, it would be really easy for me to debug what's going on with either one of these two applications. So now I can see, all right, it's posting, and I can inspect the new event that just happened. So we sent this event about a minute ago or so, and yeah, as you can see, it says 17:43:47, but that's at global standard time, so that's not Pacific time. But the minute and seconds match this. It was about a minute ago, so perfect. Now let's continue to run this and execute this, and we should stop right after or right before we send the push notification. So now I can again inspect response.resource and make sure that two events are showing up in the content of my database. So if I hover over here, now I can see there's two events. There's one and then a second one that eventually gets cut off. But that's all we need to see. Also, if I return to my Document Explorer in Azure, I can confirm that the second event was just created. And here it is. The one we sent didn't include all the second metadata, but this actually includes the exact time it was triggered, which is awesome. So now let's continue execution of this and remove the breakpoint so that we don't keep hitting it. And hit F5. Great. I get the push notification because my device is registered. I get a response saying it was OK. And I also see that the message content should be the new event that I just created. Oops. Content like 66. We don't need to go into all the JSON, but it's essentially just going to be the contents of the document. So the last thing I want to do, I'll continue debugging the live service. Actually, it's running now. I don't need to. I've confirmed it's working. I'll close this version of Visual Studio. I'm going to stop execution of my IoT app now that I'm pretty confident it works. And I'm going to Control F5 so that it deploys the IoT application without debugging. That way, I can work on the next part. So now that we've got the IoT application working, and we have the website working, all we need to continue with is the data visualization app. So what I did for the data visualization app is I utilized the XAML UI toolkit for data visualizations, which is simply a NuGet package, to create a couple of different graphs on my data that I operated on. Now, I'm not going to go through all the code, but I do want to make some slight updates to my data visualization app. So I've already created the project, and I'm just going to go ahead and add existing project. Whoops. And I'm going to go to my desktop, .NET Conf, data client, and add the project. So let's just run this first and see what we look at before we do anything else. Set a startup project, make this x86, and local machine, perfect. So what you'll see here is an app that I worked with a designer a little bit on to kind of visualize data in a meaningful way. Unfortunately, though, we only have two pieces of data. So what we should see here is two pieces of data being registered on this application. So it's going to load the data from the live service, which will take just a second. Great. So I see there's currently 2 people in the store. The average number of customers per day of week on Wednesday is the only day that people have ever entered. And this is tracking data for the last 5 weeks. And finally, the number of customers per week, well, I only have 2 customers on the week starting of June 5th. So let's make this a little bit more interesting by adding some data to our document database. So in document DB, one of the other really powerful things is that I can edit the document directly from this editor. So I have some data that I want to enter within my records. I'll overwrite these. And here are all of my different events. And you can see that this scales pretty decently to thousands and thousands of events that have occurred over the past 5 weeks. So now let's run this again and see if we get some more interesting charts. Great. Now I see some real meaningful data. Yesterday I can see the busiest time of day was 3 p.m. That's reasonable. I can see how many people have occurred over the last, or how many people have entered my store over the last 5 weeks. And it's encouraging that 5/15 is the busiest because that's when we were running a promotion. And I can also see what's the busiest day of the week. Now, what's also really cool is because of the push notification, all of this will update as soon as I trigger an event with some slight delay. But let's go ahead and try it out. So I'll do an entry event by swinging my hand through. And this should send a message to the endpoint and then increment the current people in store to 9. It also says this has now been refreshed as of right now. And I could do the same for exit, and now the current people in store should trigger to 8. And it's pretty quick. So this is live data. As soon as someone enters or exits the event, I can see exactly what's happening. So the one thing I want to update to here is the header. Everything looks okay, but the header's not too great. So what I'm going to use is a tool called XAML Edit and Continue that will be coming with Visual Studio 15. So the first thing I can do is add this overlay bar for XAML UI debugging to figure out exactly where these items exist. So I can see this is my document outline with the exact text block I want to modify. Not only that, but I can edit it directly in the document. So really all I want to do is make it a little bit bigger. Let's try 30. So here is my continuously running application. Let me go ahead and get rid of that for now. And I can see that it updated right away. I can see that this is now 30. Let's make these next two a little bit bigger as well. Not quite as big because it's not the title, but let's try 20. Great. So now I can see my header looks much better. The app is looking pretty decent. I think that's all I need to do right now. So the last thing I mentioned, let me go ahead and stop this real quick, is that I want this to look good on phones too. Now, I'm running on a laptop, so the emulator takes a little bit of time. So I'm just going to demonstrate using my local PC by adjusting the width of my application. Not only does this look better on phone, but it looks better on PC when I make the application not very wide. So all I needed to do was add about 20 lines of visual state management for my application, and I'm using grid controls as my layout controls. So I'm just modifying the heights and widths of some of the rows and columns within my grid, and I'm adjusting where some of the controls live in that grid. And that's it. So this literally took about 10 minutes to adapt my UI for phone. And let me demonstrate what that actually looks like in action. So here's skinny view, what could be more traditionally known as maybe a big phone here. And as you notice, the updates I made to the header persisted through each deployment, so I can edit my application and continue working, and it all saves. But here's what it looks like on a phone, so I can scroll through all of the different charts. As I make this wider, you can see it adapts perfectly, and I'll show you the exact point at where it happens. There you go. And all of the controls grow adaptively to match the screen size. It's pretty excellent. Great. Let's return to PowerPoint. Oops, I lost place in my PowerPoint presentation. So as you can see, we've implemented our Azure web app. All we really did was added a single controller that had two methods, a get and a post method. We had all of our services running. We implemented the entire IoT application. It's really just initializing the GPIO pins and tracking when the events change, which is pretty simple. And then we created a data visualization app using open technology like the XAML UI toolkit for data visualization. All of this was pretty easy to do, and it's a full end-to-end solution that helps my friend meaningfully analyze the data for their store. So that's all I have for you, and I'm happy to take some questions with the remaining 4 minutes. I hope you enjoyed this. Let's see if we get some questions. No questions so far, all right. Well, if you do have any questions about this, I will be open sourcing it as soon as we're ready. It should be a couple of weeks. I'll make sure to update the video with the link to the repo, and you should be able to download all this code and try it out for yourself. I'll also include an instructional document to register for the Azure services that you will need for this demonstration. If you have any questions in the future, you can reach me at pm@mike on Twitter or dejacko@microsoft.com. Thank you.